Hello friends, welcome to today's session. In this session, we'll be seeing how we can design a typical staircase. Let us consider the floor height between the ground floor and the first floor is 3 meters. Then the first landing of the staircase is at a height of 1.5 meters from the plinth level. So in this staircase, we have considered two flights of stairs. That is, this is the first flight and this is the second flight. In the second flight, the staircase is supported on a beam, and the first flight, the staircase is supported on a footing, and in between the staircase will be supported on the wall. So first what we have to do is find out the distance between A and B. That is, we have to find this inclined distance, then add this straight distance. This distance is 1 meter, that is usually the landing width will be given as 1 meter. So the distance between point A and B, that is total length of stair, we can take it as 309 cm plus 120 cm, that is 430 cm. Now let us see how this 309 cm we have obtained. So 309, this is the inclined distance, that is the square root of 1.5 meter square and 270 meter square, which I have given here. So how we have obtained 270 centimeters? We have taken the riser of the step as 15 centimeter and the thread of the staircase step as 30 centimeter. So from this point A to up to this point, we will be having 9 threads. So the distance we will be getting as 9 into 30 centimeter, that is 270 centimeters. Now the wall thickness I have taken as 20 centimeters. So we will be getting from this point to B as 1 meter plus 20 centimeter, that is 120 centimeters. Now let us assume that point A and B are simply supported, and let us take the thickness of the staircase slab, that is this distance, as 10 centimeters. That is what we have assumed here. Now let us take a extra 3 centimeter thickness to incorporate the weight due to the stair, that is this rectangular staircase portion weight and the step finishing weight. So the total thickness of the slab of the staircase will be 13 centimeters. This 13 centimeter thickness will be considered for calculating the dead load due to the staircase. The dead load is given as the thickness, that is 0.13 meters, which we have calculated here as 13 centimeters. Then multiplying that by the self-weight of the concrete, that is 25 km per meter cube. Then the width of the staircase. The width of the staircase, that is in the direction, will be 0.9 meters, that is 90 centimeters. So the dead load is equal to 3 km per meter. Now the lie load is given by 3 km per meter square into the width of the staircase, that is 0.9 meter. This 3 km per meter square I have obtained from IS 875 part 2 page number 7, which you can refer. In that, all the live loads at different areas of the building which we have to take is given. Next, the total load on the staircase is given by dead load plus live load, that is equal to 5.7 km meter. The design of a staircase is nothing but design of a one-way slab, because in staircase the support is given at this point B and A, and if we take in this flight the support is from B to this point where the beam is coming. So we can consider this staircase as a slab which is supported at this extreme 2 points, and we can go ahead with the design. The width of this staircase slab will be 0.9 meter, that is 90 centimeter, which you can take as per the rule of dimensioning of staircase. So it can be like from about 80 centimeter if the space is constrained to about 1 meter, that is typically in a house. And if you have to consider this staircase in some public buildings like school, colleges, offices, etc., then the staircase width will be increasing like from up to 1.5 meter, etc. So that is the width of the staircase which will be varying. In this case, we have taken as 90 centimeter. So To design a slab, we have to find the bending moment. So as we have considered this slab as supported at points A and B, and at this point as simply supported, the bending moment is given by WL square by 8. So in this case, W is 5.7 kN per meter, which we have calculated here. Then the length is 4.3 meter, that is which we have calculated here. So the bending moment is equal to 13.18 kN per meter. And applying factor of safety of 1.5, we will be getting bending moment is equal to 20 kN per meter. For this 20 kN per meter, we have calculated the area of steel as 12 mm dia bar at 150 mm center to center. This area of steel we have calculated in the same way as we have calculated the area of steel for a slab. And how we calculated the area of steel for a slab, we can check out by clicking the link which I have given in the top, or you can see the description section below. In that I have explained how we can do the design of a slab using manually, and I have explained it with the help of an Excel sheet. So in this case, I will be just going through the design of that slab using Excel sheet. So this is the Excel sheet which I have prepared for the design of a slab. In this, the bending moment will be giving us 20 kN per meter, that is which we have calculated here. Then the Fi that is of steel is 500 Newton per mm square, that is we are using Fe 500D steel, and the FCK that is 25 Newton per mm square, and the diameter of the reinforcement bar will be using 12 mm dia bar, and the clear curve in a slab is 15 mm itself, that is as per IS code, and this D that is the total thickness of the slab is 10 cm, that is 100 mm itself. Then this B that is width of the slab we have taken as 900 mm, that is 90 cm. So after inputting these data, we will be getting the area of steel here, and the minimum area of steel which we have to provide is here. So we will be getting the area of steel as 733.2 mm square. This D is the effective depth of the slab, and in this box we have to enter the area of steel which is maximum of this both. So in this case, the maximum of this both is 733.2. So we will be entering here as 734 mm square. So based on that, we will be getting spacing of the reinforcement which we have to provide. That is, we have to select the minimum of these three values. So minimum of these three values 154.2 mm. So we will be rounding it off and giving us 150 mm. So we have to provide 12 mm dia bar at 150 mm center to center. And if you take the area of steel as 108, that is minimum area of steel which we have to provide in the opposite direction, that we can see when we are seeing the staircase detailing. So in that case, the spacing of the reinforcement will come out to 237, that is the minimum. So we will be considering as 200 mm center to center. So now let us go and see how we can do the detailing of this reinforcement of the staircase slab. The reinforcement of the staircase is given in SP34 in page number 145, you can refer. So this is the typical detailing of the staircase having an intermediate landing. So here I have drawn the detailing of the staircase reinforcement. So from this you can understand in a better way. So starting from the beginning, this is the footing and this is the plinth. So this is typical fitting detailing. And from here, the staircase first flight slab is there. So the first reinforcement bar will be starting from here, and then it will go up to here, and this will extend up to here, and it will go to the top side of the first landing slab, then it is bent down. So this reinforcement is our main reinforcement. So spacing on the reinforcement detail is as per we have calculated, that is 12 mm dia at 150 mm center to center. And in bottom, the other reinforcement is a reinforcement bar extending from here, that is we have marked as 150 mm this distance, and will extend to the footing. And the other reinforcement will extend from here, that is from a distance of 950 mm, and it will extend to the other side of the footing. This reinforcement in the top side is also given based upon the assumption that if some fixity comes in this area also, that is a negative bending moment will be there. So it is better to provide a reinforcement to the top side of the slab in this beginning portion, so that the fixity, some fixity might be coming, that will be taken care of. So this is the main concept behind the giving the reinforcement of the slab in this beginning top portion of the slab also. And this distance we have obtained from SP34 itself, which you can see here. Here it is 150 mm is given, and this second bar like we have obtained as 950. We have obtained it from here, that is greater of LD, that is development length, that is in our case is 48D we can take, or 0.3 L have to given. So that value comes around to 950 mm. So in this other side of the slab also we are given a top side reinforcement also here, that is which extends from this point and extends to the top side up to 950 mm, and the other one will start from the bottom and it will extend up to 600 mm, and this 600 mm we got from SP34 itself, that is we are taken as LD or 0.15 L, that is the X is marked here, so it is same as here. So for the second flight, this staircase will begin from here and extend up to here and to here. So this is the reinforcement of the beam. So in this case also the main reinforcement will be in the bottom side, which we have calculated as 12 mm dia at 150 mm center to center. So that reinforcement will be starting from here. It is bent and it extends to the top side of the landing slab in this second flight, and it extends up to here. Then the reinforcement in the top landing portion of the staircase start from here, that is 950 mm. It is similar to the case in the first flight. So it goes from here to this side and the other one to the bottom side, that is which is having a distance of 600 mm this staircase flight. And in this bottom side also the reinforcement starts from the bottom, then it extends to the top side of the slab for a distance of 950 mm. And the reinforcement in the perpendicular direction of this main reinforcement is given as the minimum area of steel which you have to provide, that is 12 mm dia at 220 mm center to center, which if you recall we calculated from the Excel sheet for minimum area of steel. And the thickness of the slab we have provided as 100 mm. And if you take a typical detailing of this staircase step only, you can see that we have to give a detailing as per this, that is a 12 mm dia at 220 mm center to center spacing and 2 8 mm dia bars. If we give in these steps, it will be better. Usually this detailing or reinforcement is not provided in these steps, but if we provide then it will be better. So this is how we prepare a typical detailing of the staircase. We have started an online ETABS certification course workshop. In that we will be learning how to analyze and design a multi-story building, and this is a course structure which you can go through. So to register for this, I have given the link below, so don't forget to check that out. So if you like this video, don't forget to like, share and subscribe. Thank you.